This is a short overview of mineral nitrogen behaviour in cropping soils, using data gathered from the Sustainable Vegetable Systems Regional Monitoring Programme. This graph shows the quantity of mineral nitrogen in kilograms per hectare across 18 months. The background colours of the graph indicate what crop was in the field, or if the field was in a fallow period. The green area chart is a visualisation of the quantity of mineral nitrogen in each of 3 soil depth layers. These mineral nitrogen readings were obtained from soil samples collected monthly. From top to bottom, these layers are 0 to 15 centimetres, 15 to 30 centimetres, and 30 to 60 centimetres. For most crops, the top 2 layers represent the bulk of the primary root zone, though for many crops, including carrots, the root zone will extend below 30 centimetres. The dashed orange line indicates the crop nitrogen uptake, with the crop in this instance being carrots. This plant uptake is based on real biomass measurements as opposed to a modelled value. The final component of the graph are the black lines, which represents the quantity of nitrogen added to the system in the form of fertiliser. Starting from March 2021, just before the carrot crop is planted, there is about 35 kilograms of nitrogen per hectare in the top 30 centimetres of the soil. After the carrot crop has been planted, this begins to change, with mineral nitrogen in the root zone steadily decreasing as it is flushed deeper into the soil by rainfall and as the carrot crop slowly begins to take up nitrogen. 2 small fertiliser applications then increase the level of nitrogen available to the growing carrot crop, which starts to rapidly take up nitrogen from the root zone throughout winter and spring. By the end of spring, the carrot crop is ready to harvest, and there is little mineral nitrogen left sitting in the soil. This is optimal from an environmental risk perspective, as after harvest there is no nitrogen uptake from the crop, so any residual nitrogen is vulnerable to leaching. Going into the summer months, mineral nitrogen levels in the soil increase at a steady rate. This increase can be attributed to favourable mineralisation conditions, as well as the breakdown of crop residues. The breakdown and subsequent mineralisation of the carrot tops left behind after harvest likely made a significant contribution to the increase in available nitrogen, as up to 40% of the total crop nitrogen content was incorporated into the soil following harvest. As the following crop is onions, there is limited opportunity to plant a cover crop like there was prior to carrots. Over the fallow period, mineral nitrogen accumulates to a peak of over 50 kilograms of nitrogen per hectare in the top 30 centimetres of soil. However, subsequent winter rainfall flushed this accumulated nitrogen into the lower depths of the soil. Because mineral nitrogen supply can increase or decrease rapidly based on numerous variables, each cropping field will have its own characteristics, influenced each season by the circumstance and environmental factors unique to that field. In this example, the grower has had as little as 5 kilograms of nitrogen per hectare available to their crops in the root zone, or as much as 50 kilograms of nitrogen per hectare. Knowing this quantity of nitrogen sitting in the soil is imperative for growing a successful crop while managing environmental risk. This is why it is important for growers to have a firm understanding of the nitrogen cycle, as well as to test their soil's nitrogen content frequently, whether by laboratory analysis or using the nitrate quick test.